Hello again. This video is for learning intention number 28, and here we're going to be reviewing mutually exclusive events. And I'm hoping this is revision as well, and this is going to be part 2 of learning intention 28. And I have a deck of cards again because I think it's a great example to show all these probability formulas that you need to know. So last time I gave you a question and we looked at it in two ways. We're going to do that same thing again. I'm going to give you a question and we're going to look at it in two different ways. So my question is, what is the probability of selecting a diamond or club at random? Alright, well, let's do it the old-fashioned way. We want a diamond or a club, so we've got our sample space here. So let's see, we want the favourable outcome, so that's all the diamonds and all the clubs. So the probability of drawing a diamond or club, I'll do my best club here. Well, it's not hard to see that it's 26 out of 52 or a half. That simplifies to a half, which makes sense. So looking at the sample space, you can see, well, half the sample space is a favourable outcome. So the probability of selecting a diamond or a club at random is a half. But I want to emphasize what mutually exclusive events are. And I want to do this by doing the problem in a different way. The probability of drawing a diamond equals something, and the probability of drawing a club equals something as well. These two events are what we call mutually exclusive. The probability of drawing a diamond is mutually exclusive. Sorry, the event drawing a diamond is mutually exclusive to the event of drawing a club. There's a few ways to look at it. If you look at the event of drawing a diamond, it doesn't overlap with the event of drawing a club as well. In the previous video there was some overlap. Here there's no overlap. They mutually exclude each other. Mutual means it's shared. So the word mutual, if you have like mutual respect, it means you respect each other. So mutual means like shared, and exclusive means to exclude. So they share the exclusion, like they don't share anything. They don't have anything in common. In other words, you can't draw a card that's both, if I draw a card, it can't both be diamond and club. You know, that card doesn't actually exist. So these events are mutually exclusive because they can't happen at the same time. That's what mutually exclusive means. Well, what's the probability of drawing a diamond? Well, that's 13 out of 52, which equals a quarter. What's the probability of drawing a club? That's 13 out of 52 equals a quarter. Why is this important? It's because, I'll just make it clear that that doesn't exist. It's because we have another special formula that says the probability of A or B occurring is the sum of the probabilities of A and B if, and there's a big if, A and B are mutually exclusive. So this only works if A and B are mutually exclusive, if they exclude each other, if they can't happen at the same time. So you can only apply this formula if the two events can't possibly happen at the same time. So let's apply this formula. Well, what's the probability of drawing a diamond or a club? Well, we know that they're mutually exclusive, so we know it's the probability of drawing a diamond plus the probability of drawing a club, and we know those probabilities, and a quarter plus a quarter gives us a half, so it gives us the same answer. Notice as well that there's no intersection between these two events, so they don't overlap in any way. So another way we can say that is that this implies, so that if they're mutually exclusive, it applies that the intersection equals 0. In other words, the probability of having drawing a diamond and a club in the one card is 0, because this card doesn't even exist. I hope that helps your understanding of mutually exclusive events, and if you have been, thank you for watching.